properties of the definite integral. Once you really understand what's going on with definite integrals, these actually become quite obvious and you don't really need to memorize them, but for now I'd make sure that you do memorize them. There are many properties of definite integrals, and we're not going to look at all of them in the course, we're just going to look at some. The ones that we're going to look at in this section are that the integral from a to b of f of x dx plus the integral from b to c of f of x is equal to the integral from a to c. So it looks like an integral from a to b and then b to c is the same as just going directly from a to c. And a diagram explains this really well. So if we think about the integral from a to b of f of x dx, that's going to be this gold area here. The integral from b to c of f of x would be the blue area here. So if we integrate all the way, it must be the total area. So the total area is gold plus blue. So this area, as we discussed, is the integral from a to b of f of x, and this one is the integral from b to c of f of x. Now the next one is that the integral from a to b of k, where k is a constant, that means it's just a number, times f of x, is equal to k times the integral from a to b of f of x. So in other words, we can slide the k outside. Again, let's look at a diagram. Here we have y equals k times f of x, and we know that that's a vertical dilation of the original function. So compared to this one, we can see that it's just been stretched upwards. And what this is saying is that this area here, the gold area, is just k times the blue area. And if you think about that, that's really sensible. You can just think of that with a rectangle. If you have a rectangle with a particular width, if you make another rectangle with the same width 3 times as high, it will have 3 times the area. Now this one here says the integral from a to b of f of x plus g of x, so we're adding two functions together, is the integral of f of x plus the integral of g of x. Note the limits are all the same, they're all a to b. So if we have y is f of x like this, then what we know is that this is the gold area. And we're adding to it the blue area, and the blue area would be this. If we combine the two functions, f of x plus g of x, then we get this purple type area, and that purple type area is represented by this side. And so what this is telling us is that this area is equal to those two added together. Now over here we have the integral from a to b of c f of x, so that's some constant times f of x plus a different constant, or it might be the same constant, multiplied by g of x. And we're saying that that's equal to c times f of x from a to b and d times g of x from a to b. And we could slide the c outside here and the d outside here as per a previous property that we looked at. And so this one just follows from this one, because we just can consider cf of x to be one function and dg of x to be another function, and then it just follows naturally. Another property is that the integral from a to b of f of x dx is the negative of the integral from b to a of f of x dx. So if we switch the limits, we change the sign. Now this is really important and is used in lots and lots of applications. So make sure you really do know this one. This is simply because the left-hand side is f of b minus f of a, where capital F is the indefinite integral of small f, and the right hand side is f of a minus f of b. And you know just from factorizing in the past that we could write that as minus f of b minus f of a. So it really is as simple as that. It's year 9 maths.